So if we're analyzing a graph, trying to figure out what the equation is, it helps us to know some of the main reference points for the standard cubic function. So three of the standard reference points that I graphed in my original picture are -1, -1, 0, 0, and 1, 1. So these are kind of our basis. You notice that the x values are each changing by 1, and the y values, in this case, are each changing by 1 as we go from point to point. So first thing we want to do, we want to find the point of symmetry. That's very similar to our vertex in our work with parabolas. So that's going to be here. It's kind of the middle point here. It's at 2, 1. So that's telling us it's originally here at 0, 0. That's telling us how far we're translating left, right, and up, down. So now what we do, we want to identify A. We need to see if we're reflecting and then if we're doing a stretch or compression. So the one thing you want to look for, again, I said in our original reference points here, x's and y's are each changing by 1. Essentially what we're looking at when we're giving these reference points here in our picture, which ones aren't changing by 1, because that's what's going to be having a stretch or compression. So as we look at the x values, we're going from 1 to 2 to 3. Those are each increasing by 1. If we look at the y's, however, they're changing from -2 to 1 to 4. So that means our y's are changing. How much are they changing? From -2 to 1 is a change of 3. From 1 to 4, it's a change of 3. That means A is going to be 3. Now, another way to check this, if you're unsure about this aspect, what you can do is take the original equation, f of x equals a x minus h cubed plus k. Take what we know hk to be, plug it in. If it helps you, you can change the f of x to y. Since h is 2, that means we move to the right 2. So it would actually be x minus 2 cubed. We moved up 1, so plus 1. Once you have this just based on that point of symmetry, that original 0, 0 point, you can pick one of the other points. So I picked 0.34. If you plug those values into the equation, you should be able to solve for x from here. So I picked the 0.34, so I'll plug in 4 for y equals a, x minus 2, x was 3, minus 2 cubed plus 1. 3 minus 2 is 1, 1 cubed is 1, so this is just a plus 1. Solving for a, we subtract 1, a is 3. So that's a different way to find that value of a. So once we know a, again, it's kind of coming from here. Once we know a, and we know that h and the k, we can plug it into our equation. F of x equals our a value, 3, x minus h is our 2, we move to the right, cubed, plus 1. So that's our equation there. Then we're going to do one more of these. Similar idea. So first thing we do, we find the point of symmetry. When you're given these 3 reference points, it's going to be the one in the middle. So it's at -2, -2. So we need to identify A. So again, we're looking for, are we changing in y or are we changing in x? So if we notice the x values, they're increasing by 1, -3, -2, -1. So that's good. That means we're going to be changing in y. So how much are we changing? From -5 to -2, that's a change of +3. From -2 to 1, that's a change of +3. So our A is going to be 3. Again, we can solve this another way, taking our standard equation, plugging in our h and k values. So again, we're moving to the left, so it's going to be x plus 2 cubed, and then down -2. Picking one of our other coordinates. So we can pick that -1, 1. Plug in the y value of 1 equals a x, which is -1 plus 2 cubed -2. -1 plus 2 is 1. 1 cubed is just 1, so this is just a -2. We add the 2. We, again, get that a is 3. So last thing we do, we put it all together into our equation. F of x equals our a value, 3. X minus h, so minus -2, which is plus 2 cubed -2. And those are how we find the equation based off of a graph with some of the reference points.